Let's now take a look at the pancreas. Now the pancreas is both an exocrine and an endocrine gland. Now what does that mean? Well, endocrine means that it releases hormones into the bloodstream, and exocrine means it releases chemicals into hollow tubes and hollow organs. So let's first draw up the pancreas, and then we'll talk about very quickly both of those two functions that the pancreas plays. All right, so first thing I want you to draw up is we're going to draw the stomach, or at least the stomach and the pyloric sphincter leading into the duodenum. And then we're going to exaggerate the duodenum, which is the first part of the small intestines. And within the C shape of the duodenum, that's where we're going to place the pancreas. Now when we look at the pancreas has a head, a body, and a tail. Okay, so we've got the head, the body, and the tail, and there's a number of ducts, so ductal systems within the pancreas that lead into the duodenum. So let's draw that up. So these are just some branches of that ductal system. And I'm just going to leave it there. I'm not going to close it off yet because there's going to be another duct that comes in that's very important. Another thing I want to draw up, I know that stomach is very small. I'm also going to draw a very small liver because the liver is not the focus of today's lecture either, but it will be of another lecture. And we're going to draw two ducts that come off the liver like this. And then we're going to have the gallbladder. And then we're going to have another duct that comes in behind. And this is going to be the duct that connects up with the duct of the pancreas. All right, a couple of other things. That when we look at these ductal cells that come off, these interlobar and interlobular ductal cells, if I was to just zoom in on this area right here, for example, we're going to find as an example, here you're going to see that there's going to be groups of cells around what looks like an open area at the ends of these interlobular ducts. So this is the pancreatic duct, and this is going to be an interlobar, and this is going to be an interlobular duct, okay? And then at the end of this interlobular duct, there's going to be a group of cells around what looks like an open cavity. Now these groups of cells here are called acini, for plural, ACINI, or they are acinous cells. Acinous, or acini is plural. We're going to talk about exactly what those cells do very shortly. Now a couple of other things. What I want to do is now name or label what all these tubes are called, okay? So first thing is if we start up here at the liver, we've got the left and right hepatic duct. So we've got the left hepatic duct and we've got the right hepatic duct. That's those two there. And they come together to form the common hepatic duct. Common hepatic duct. Then you've got the gallbladder right there. And then the duct of the gallbladder is called the cystic duct. That's the cystic duct. And then when the cystic duct comes together with the common hepatic duct, that's going to be the bile duct. Now you can see that the bile duct comes together with the pancreatic duct. There's so many ducts involved here. Pancreatic duct and bile duct come together, and they come together at what's called the ampulla of Vater. The ampulla of Vater. Let's highlight that. Ampulla of Vater. And then here we have a sphincter in which this bile duct and pancreatic duct, which come together, will empty their contents into the duodenum, and this is called the sphincter of Oddi. Sphincter of Oddi. Okay. Now, we've set the scene. We can talk about exactly what happens when the stomach decides to squeeze the contents, that chyme that's within the stomach, through the pyloric sphincter, which is remaining relatively tight. Remember, the stomach has these muscular contractions. It's got 3 muscular layers. Instead of just the longitudinal and the circular, it's also got an oblique layer, which allows the stomach to start pushing chyme through, and it squirts this chyme. Sorry, you can draw that up very well. It squirts this chyme through the pyloric sphincter into the duodenum. Okay, so now we've got foodstuffs moving through the duodenum. Now, this foodstuff's going to be proteins, fats, carbohydrates. Okay, now remember, this is important. In the mouth, you have amylase that's secreted by the parotid gland. So the parotid gland secretes amylase, which breaks carbohydrates down to sugars. So now we've broken down one of the 3 proteins, fats, or carbs. Once we get down to the stomach has hydrochloric acid that denatures proteins, that just unfolds them, but also has these proteases, right? And these proteases then are molecular scissors that cut up proteins. So now we've digested, chemically digested proteins. What haven't we digested yet? Fats. So this is a very important point when it comes to the duodenum and the pancreas, is that it plays a very big role in fat digestion. I haven't told you the specifics yet, but without the pancreas, 60% of the fats that you digest in your foodstuffs would not get absorbed. All right, and we'll get back to that point. So we've got proteins, fats, and carbs broken, some of which are broken down, but predominantly there's a lot of fat coming through here. Now, as this foodstuffs move through, I'm just going to rub off the sphincter of Oddi here so I can highlight some important points. As this foodstuffs continue to move through, it ends up stimulating some cells in the duodenum, and these cells are called enteroendocrine cells. So these are enteroendocrine cells. I'll write it down here. Enteroendocrine cells. Now, entero is referring to the GIT, that's easy. Endocrine is referring to the endocrine system, which means it releases hormones into the bloodstream. And what hormones does it release? Well, these enteroendocrine cells release secretin and cholecystokinin. So, secretin and cholecystokinin. Secretin and CCK for cholecystokinin. Now, this is important. What stimulated their release? What stimulated their release was foodstuffs moving through and acid moving through. Let's first start with CCK. What does cholecystokinin do once it's released into the surrounding bloodstream? Well, first thing it does is it will go to these, or one of the things it does, I should say, it will go to these individual acinar cells and stimulate them to release the products that they create. Now, what products do they create? Acinar cells produce something called pancreatic juices. Let's write that down. Acinar cells produce pancreatic juices. And the pancreatic juices, what we call pancreatic juices, are proteases, amylase, and lipase. Protease, amylase, lipase. Breakdowns proteins, fats, carbs. They cumulatively are the pancreatic juices. Now, an important point is that the proteases, for example, are inactive in the acinar cells and are still inactive when they're released from the acinar cells. Now, what stimulated them to release? I told you it was the CCK. So CCK stimulated acinar cells to release these pancreatic juices into these interlobular and interloboductal cells, and then into the pancreatic duct, where it'll finally be released into the duodenum. But they are inactive, and they're inactive because there's an inactivator within these pancreatic juices that keep them inactive. Once they get to the duodenum, there are certain chemicals called enterokinases. So what I've drawn up here are enterokinase, and these enterokinases activate the inactive proteases. Okay, so these inactive proteases, for example, is trypsinogen. If it ends in OGEN, it's inactive, usually stored and needs to be activated. So trypsinogen, once it's activated, chop off the OGEN, it becomes trypsin. And the great thing is, once these enterokinases activate the proteases, what happens then is that one activated protease will then be able to activate the rest of the proteases, and will be able to activate any other pancreatic juices that need to be activated. And therefore they can start doing their job here. The reason why they're inactive in the pancreas is for obvious reasons, so they don't digest the pancreas itself. Very important. Now for certain diseases, such as pancreatitis, there's a couple of different causes of pancreatitis. The two major causes of pancreatitis are going to be alcohol abuse and also gallstones. Gallstones blocking the pancreatic duct here, coming from the gallbladder. Gallbladder is going to be filled with bile, and bile emulsifies fat, so it's like a detergent, breaks fats apart. But there's one of the major components of bile is cholesterol. And if you have too much cholesterol, it starts to solidify or crystallize and form stones. And some of these stones can block this duct. If this happens, all the pancreatic juices that are released tend to back up, and if they stay there for too long or they become in quantity too much, they can start to activate themselves and start to digest the pancreas, which isn't a good thing, okay? So what's happened? Foods come in, stimulated secretin and cholecystokinin. CCK so far, it's been released into the bloodstream. It's activated the acinar cells to release pancreatic juices, which are the inactive proteases, amylases, lipases. They travel down the pancreatic duct into the duodenum, where they're activated by enterokinases and now can start chopping up foodstuffs. But the fats that have come through, remember, it's fine for proteins, it's fine for carbs because they're already partially digested from the parotid gland in the mouth and from the stomach. But fats, we know that when you cook with fats, cook with oils, they form these big globules. We need to break those globules down into more manageable pieces. It's hard to get the molecular scissors to chop them up because they're too large. So we need to break them up into smaller, tiny globules, which aren't called globules, called micelles or micelles. And what produces these? Well, that's the bile in the gallbladder, which means CCK also travels to the gallbladder and stimulates the gallbladder to contract, releasing the bile that it has stored, which it has also received from the liver. So this bile then travels down through the bile duct, and again, with the pancreatic juices, will move into the duodenum. The bile, just like detergent, emulsifies the fats, breaks it up into manageable pieces, and now the lipases can chop it up. Again, without a gallbladder, for example, from a cholecystectomy, that's removing the gallbladder, you have reduced capacity to break down fats and digest them, so you may have to change your diet a little bit, reduce the amount of fats potentially. Okay, now what we haven't spoken about is the secretin. What does the secretin do? Well, the secretin specifically is stimulated from the acid that's been pushed through the duodenum. CCK was predominantly stimulated by foodstuffs, secretin by the acid. And what secretin does is again, it's a hormone, so it travels through the bloodstream, but it doesn't go to the acinar cells. It goes to a cell type that's sitting across the ducts here. These are ductal cells, also known as intercalated ductal cells. I'll write it down here, ductal cells. And what do the ductal cells release? The ductal cells release bicarbonate. Bicarbonate. And bicarbonate is HCO3 negative. And what bicarbonate does is it buffers hydrogen ions. It is a mop that absorbs hydrogen ions. So this is important because I told you that the stimulus for secretin was this acid coming through. And we know that acid is simply just an abundance of hydrogen ions. Releases secretin. Secretin stimulates these intercalated ductal cells. They release bicarbonate into the pancreatic ducts. They travel through into the duodenum and neutralize the acid. This is wonderful because unlike the stomach, remember the stomach has mucous membranes in here and produces its own bicarbonate to protect itself. That's why the stomach doesn't digest itself. The duodenum does not have such protective mechanisms. So the pancreas is relied upon in order to release this bicarbonate for protection. All right, what's the last thing? Well, actually, another thing I'd like to say is that in addition to secretin and CCK stimulating intercalated ductal cells and acinar cells, Acetylcholine does this as well. Now, acetylcholine, I'll write it down here. Acetylcholine, and I didn't highlight that the secretin here, but acetylcholine as well. And acetylcholine is a neurotransmitter, especially the most pronounced neurotransmitter for the parasympathetic nervous system, which is the nervous system that innervates the GIT to tell it to start secreting substances, because it's the rest and digest part of the autonomic nervous system. So the enteric nervous system, all right, which is comprised predominantly of the vagus nerve, the parasympathetic nervous system, will release acetylcholine and help stimulate this process as well. All right, last thing I want to talk about is this is the exocrine function. Okay, this is the exocrine function of the pancreas, because all these pancreatic juices were released into ducts and the bicarbonate was released into ducts. Now we need to talk about the role that the pancreas plays that releases hormones, the endocrine function, where it releases hormones into the surrounding bloodstream to travel around the body. You may or may not know that the pancreas is important for a disease called diabetes, more so important for controlling blood sugar levels or blood glucose levels. So there are groups of cells just spotted all around the pancreas. And these groups of cells have a couple of different cell types, but I'm only going to talk about two. In the middle, more pronounced, you have beta cells, and I'm writing the Greek beta here. And around the beta cells, more on the periphery, we've got alpha cells. Okay, what do these beta cells, what do these alpha cells do? So, firstly, these groups of cells here are called the islet of Langerhans. Islet of Langerhans. Now that may be something you've heard of before. The islet of Langerhans contains the two predominant cell types that release insulin and glucagon. So the beta cells and alpha cells release insulin and glucagon, but which one releases which? Well, the beta cells release insulin and the alpha cells release glucagon.